In this section, we will look to implement a machine learning-based algorithm to train a linear model to fit a set of data points. As this course does not assume any prior knowledge with deep learning, we'll begin our discussion with the notion of supervised learning, what it is and how it relates to this course. If you've taken one of my deep learning courses before, the material in this video should be very familiar to you. We will begin with a very broad definition. What is machine learning? A simplistic definition is that it's the concept of building computational algorithms that can learn over time based on experience, such that rather than explicitly programming a hard-coded set of instructions, an intelligent system is given the capacity to learn, is given the capacity to detect and predict meaningful patterns. While one can distinguish between supervised and unsupervised learning, let us consider supervised learning. In supervised learning, the learner is trained and makes use of datasets associated with labeled features which define the meaning of our training data. That way, once introduced to newly inputted data, given a new input, the learner is able to predict a corresponding output. Before discussing any more theory, let's jump into some code. Alright, so the first step being open up a new collab project. I've already went ahead and performed the torch installation and imported torch and named my project linear regression. Feel free to pause the video and get this boilerplate configuration up and running, because the ultimate goal of this project will be to create a dataset which generally will follow a linear pattern. Then we'll declare a line, a linear model, with some random set of parameters which, chances are, will incorrectly fit our dataset. However, then we make use of a simple optimization procedure known as gradient descent, which is often used in many machine learning algorithms. What this optimization algorithm will do is minimize the error function of our linear model, and it keeps doing so until the model is trained to fit our data really well. Our first step in this venture will be to declare a linear model and use it to make predictions. So we initialize two variables, w and b. And the reason for this being, we know the equation of a line can be modeled as y is equal to w times x plus b, where w is the slope, the weight, and b is the bias term, the y-intercept of our line. These are the parameters which distinguish our line, and ultimately with linear regression, provided with a bunch of data points, we first start with some linear model which most likely will not fit our data well. We then use these data points to train a linear model to have the optimal weight and bias values, that of which will provide us with the line of best fit. And then after training this model to have suitable parameters, given an input x, we can then use this linear model to make a prediction y. Alright, so back to our code, we set w is equal to torch dot tensor, and we will give the weight some random value, say 3.0. And as we will be training our model, we will require the gradient of our linear function. So requires grad must equal true. All right, don't worry about why we did this for now. It will be more apparent to you later on why we need the gradient, but for now we do the same thing for the bias term. We'll just copy and paste that, call this b, delete this one, and instead of a value of 3.0, let's change this to 1.0. It really doesn't matter. And now, given a linear model, y is equal to w times x plus b, provided an input x, we can make a prediction. We can determine the output y. And the purpose of this lesson is to show you how to make predictions with PyTorch, provided that you do have a model. To do so, what we're going to do is actually copy this, delete it, and on a new cell, we define the forward function, def forward. And this forward function receives the input, the independent variable, the x value, and this input is going to be passed into our linear model. Y is equal to w times x plus b. W and b being the parameters of our line, and then based on the input x, we predict the corresponding output y. A prediction is computed and returned. Returning y, let us now test our model by going inside of a new cell, and we set the input x is equal to torch dot tensor. We will choose an input of 2, and outputting the result of forward x, our model makes a prediction of 7. Instead of passing only one output, one can pass in many inputs. Suppose you wanted to make a prediction for the input 4 and for the input 7, respectively. Our forward function expects only one argument x, so we must wrap this up in an extra set of brackets such that it receives both 4 and 7 as separate inputs, and the computation will occur as follows. Making a prediction for the input 4 to be 13 and for the input 7 to be 22. That is all for making predictions. In the next video, we will look into a more standardized way of creating a linear model. I will see you there.